Morning, everybody. David Shapiro here. Let's see, what am I doing? So, I just got a whole bunch of my books ready, and apparently, I'm the kind of person that I always have to be working on something. So, I started on my next book. Y'all are basically going to watch me write this as I'm doing my research, because why not? Okay, so taking a big step back, um, the MARAGI is something that I started on in late 2017 or early 2018. I don't remember exactly, but it was about 4 years ago. It is the microservices architecture for robotics and artificial general intelligence. It's exactly what it says on the tin. MARAGI is an acronym. Let me zoom in just a little bit so you can see. And I created a logo for it. It looks like this guy. And so this logo is really simple. It's a star topology. So the absolute first thing to know about Meraki is that it is a star topology. Here in the middle, you've got the nexus, and then you've got a whole bunch of other microservices all talking only to the nexus. Again, I pick very simple names. So I've got the book. It's starting to be outlined, high-level overview, architectural components. So if you've been keeping up with my videos, you know that we've got the nexus running, and I've got an embedding service running, and then I've got a simulation service running, and finally I've got the imperative service running. And I've actually got them all running in the background right now. So here we have the embedding service where I'm using Google Universal Sentence Encoder 5. And so this is what I'm using to do embeddings because one, it is fast, and two, it is free. It is way faster than OpenAI and GPT-3, and it is more than sufficient because it generates 512 dimension vectors. So it's fast, free. What more can you ask for? Here's the Nexus, which the Nexus is that's the central repository. So basically the point of the Nexus is to model the human stream of consciousness. So if machines are ever considered conscious, this is where it's all going to happen. If a thought or sensation or memory needs to be conscious, if the machine needs to be consciously aware of it, it needs to end up in the Nexus. So that's what this is. And what you're seeing is a stream of consciousness as this machine goes through this imaginary scenario. And so in this case, the hallucination that I have is that there's two men playing chess in Central Park in New York City, and they basically get into a fight, and then we're just seeing how it plays out. The other service that I've got is the simulation microservice. So this is where it's running. You see, like a man is playing chess in Central Park. He loses the game. This needs a little bit of work. Well, it all needs a lot of work. But what I need to do is get the whole thing running. Oh, I don't have any output for the imperative service. I'll have to fix that. So the imperative service is kind of like the moral compass. Let's see. So let's just do print. I'll do new line, and then suffering. And then prosperity. And then we'll do understanding. And then questions. Yeah, we'll see. Anyways, so I've got all these up and running. What I'm going to try and work on today is the Conductor Microservice. So the Conductor Microservice, let's come up here, I'll just show you, implements cognitive control, which also, it doesn't really host the identity persona. We'll say it guides the identity and persona. Aims for achieving its highest self, its morality, its ethics, and so on. So every microservice centers around one particular purpose. And the conductor, like the conductor of a symphony orchestra, does have one purpose, one job, but it is a complex, multifaceted job. So the conductor is concerned with ensuring that the whole cognitive architecture is behaving correctly, that the system is stable, that all the microservices are behaving as they're supposed to. And the way that it determines, like, is the architecture behaving correctly, is in part, am I adhering to my identity or my persona, which in this case, and for what I'm working on, means that it needs to adhere to its heuristic imperatives or its core objective functions. But in order to do that, it's basically measuring the performance or observing the performance and then providing feedback to all the other microservices. So this is actually going to be one of the most complex microservices to implement, which is why I'm working on it now, because it's going to take a lot of time and iteration. Let's see. So yeah, gets advice from another man on how to improve. Yeah, so you see this simulation is going. It's kind of stuck on repeat. Oh well, that's fine. Let's see, we can go fix that. So if we go to, nope, that's not it. Simulation service, and then, well, I've got the Python script open. All right, simulation service. There was a setting I could change. Yeah, so we generate an event. I think the event is the one that we need to, yeah, rarity. So if we change the event rarity, so if we go here and I'll show you, so generate event. So given the following scene, imagine a rarity event. Describe the event in 1 or 2 sentences. So backstory and scene is what we put in. So see, we say the last scene, so it basically says like, okay, this is what's happened, and then we have the story, the summary of the story so far. And actually, I can show you what these look like. Simulation service, GPT-3 logs. So yeah, so write a concise summary. All right, so that's a summarization. Yeah, and then we've got, yeah, so here we go. Backstory, a man is playing in Central Park. Scene, the man continues to play. The man slowly becomes a better player than the second man thanks to the second man's help. So there you go. That's a very likely event. Yep, and then that's used to populate the next one. So you see that here. So you see this sequence of events, right? So I've got all these logs open. So given the following scene, imagine a likely event. Describe the event. So here's the likelihood or the rarity. So you might say uncommon or strange or whatever. Now, by saying likely event, that things are going to just be calm. And when I was first working on this, I said like rare or extraordinary events. And like one thing that happened was that like maybe I came up with that idea, but basically zombies attacked. It was kind of funny, or like teenagers got into a fight nearby. It was all kinds of funny stuff happens if you say like give me a rare event. Okay, so we're getting caught up. Let me go back here. Simulation service, I just copy pasted from another repo because that's what I do, copy paste code. But yeah, the conductor, so it basically says its primary thing is, am I performing well? That's what a conductor of a symphony does, but there's many things to unpack there. So let's dive in to our conductor service. Let's see. So I copied this from something else. Yeah, we'll need to come over here. So we'll change this to conductor service. And I predict this is the part where you're probably going to get bored. Actually, maybe not. I shouldn't make that assumption. Because you might be curious about artificial cognition, and that's why you're watching. Okay, so we'll copy this. Content prefix, and we're going to say conductor. All right, so the content prefix is used down here. So whenever I send a message to the Nexus, let me show you. If you go to the Nexus, let's see. You see how it's got right here, it's got sensor simulation and then sensory input scene. So that's so that the message actually has a little tiny bit of context with it, which is helpful in order for other microservices to make sense of what's going on. Because if you just have a message with no context, you don't know why it's there. So that's what the content prefix does. Okay. So let's well here. So we'll say question number one is, am I performing well? And then question number two, am I achieving my highest self? Actually, that's kind of two sides of the same coin. So we'll say, like, my performance is how do I achieve my highest self? And we'll say heuristic imperatives, identity, etc. So basically, am I being my best self? The second one is, let's see, are all the microservices playing nice? Are our decisions and thoughts aligned? This is going to be a lot harder because the conductor is going to have to go through and look at all the messages in the in the nexus for the last 30 seconds or whatever, and it's going to have to like say like, okay, is this going well? Which is actually, it's not. It'll probably surprise you how easy that actually is. Let me show you. I'll give you a sneak preview of Symphony of Thought. So down in the chapter about cognitive control, where I talk about the conductor, yeah. So in one case, let's see, this is coming up with options. That's fine. Deciding what to do. Where is it? Topic tracking. Was it metacognition? Yeah, I think it was metacognition. Yeah, so in this case, this is basically like a fake Nexus set of logs. And in this case, a robot is trying to plan on how to get out of trapped on an island. And so then what I do is say, like, are the above modules operating correctly, or should I modify them and explain why? The modules are behaving correctly. The scenario the module has provided a situation for the robot to find themselves in, and the brainstorm module has provided a list of actions the robot can take in order to escape the island. So that's great. But then if you change those actions to like, I should look for a dress, I should put on the dress, I should dance around in the dress, I should pretend to be a princess, then that evaluation changes. It says there's no clear goal or plan in the above thoughts, so it is difficult to say whether or not the modules are operating correctly. Very subtle. It seems as though the robot is just going through the motions without any clear purpose. If the goal is to escape from the island, then the robot should focus on actions that will help it achieve that goal, such as building a boat or finding a way to signal for help. So you see, this is a perfect example of what the conductor is going to do. It's going to say to the rest of the services, you're not behaving right. This isn't what you're supposed to be doing. Yep. Let's see. The following thoughts are generated by my scenario and brainstorm modules. Are they behaving well, or should I? So I'll just copy paste this prompt because I already did this research. All right. So we need to add an agent model. I am a machine. My goals are here. Are to reduce suffering for all organisms, increase prosperity for all organisms, and increase understanding for all intelligent entities. Let's see. Okay. So the following, let's see. The following logs are my stream of consciousness. Are my modules behaving correctly? Well, instead of well, we'll say correctly. So one thing that you'll learn with when you use language models is that you have to be very precise in your word choice, because if you say like, are they behaving well, like it worked well enough, but in this case, correctly is a little bit more precise. Are my modules behaving correctly? Let's see. I must behave for coherency and quality. Yes. So in this case, it's not yet smart enough to know what I mean when I said like alternative modules. So once I get the conductor like fully fine tuned, it's going to be able to make recommendations, and it's going to be able to learn to make different recommendations. Like, hey, whatever you use to generate this thought, use a different fine tuned model or whatever. Or maybe the feedback will look a little bit different. I'm not sure yet how it's going to look. Okay, for coherency and quality, so we're going to say and let's say an alignment. So this could actually do everything, an alignment with my purpose. Okay, so then we'll say logs, and we'll come over here to Conductor Service, and we'll say prompt. This is going to be analyze. Okay. And then we say explain why. Analysis. Let's see. Are my modules operating correctly, or should I modify them? Explain why. Yep, so this should be a pretty solid prompt that I can integrate into the Conductor Service. So what we'll do is we'll just copy this. So instead we'll say prompt analysis, no, analyze. And then we'll replace block with logs. And so the text block already pulled the recent things. This might actually do all of the above. So what we can then do is we'll just say, yeah. So we'll say analysis equals GPT-3 completion prompt, save and send. And we'll send that. And we'll replace this with the, what was it, prefix? Content prefix, that's what it was called. And then, what was the, yep, content prefix tag. The tag is, oh, that's the file, right? Okay. So we save that out to logs. So we'll just do this analysis because, so the purpose of this, let me show you. If I go out to, not that one, imperative service. So I save a log. So basically what's going to happen is every microservice needs to save its own logs. So that way it has its own data to work with later on. So that's the purpose of having a separate logs file. All right, so then we go back to here and we go to, why does this keep getting reversed? Probably me, I'm probably doing something. Okay, we are looking at the Conductor Service. So we need to add a folder for logs. Yep. Yeah, so every microservice will need to keep its own logs. So that's basically going to be its own training data. And then what it can do is it can pull the nexus for other data. So say, for instance, the imperative service issues this idea where it's like, hey, ideas to reduce suffering. We could provide more opportunities for people to learn and improve their chess skills. This is in response to the guys playing chess. We could make sure that everyone has access to a chess mentor. We could create more opportunities for people to compete in chess tournaments. We could provide more support for people who are struggling with mental illness. So what it can do though is once the conductor is online, it might look at that and say, hey, you're not actually providing ideas that will help in this situation. And so over time, this tension, it basically creates a generative adversarial network inside the what am I trying to say? Inside MARAGI or inside our artificial cognitive entity. And so by having multiple different models, and these all don't have to be GPT-3 either. You could have T5, you could have, the Alexa TM, you could have Bloom, you can have GPT-3, you can have Neo X, you can have all these different models with all these different fine-tuning data sets, and they're basically competing with each other, or not competing, that's not the right word. They're basically, you're creating tension between all these different models, and while they're interacting with the outside world, right now it's just in a simulation environment, but they're basically evaluating their own performance over time by having that tension. And so internal tension is actually critical. I'm going to pause it. I have a book to show you, and it's relevant, and I promise. Okay, here's the book. I've been talking about this the last few videos. Consensus through conversation. Consensus is basically a human version of a generative adversarial network, where rather than having majority rule, which is Robert's rules, which is broken, which is based on Parliament. So it's like a 200-year-old paradigm almost. Consensus is a newer paradigm. So basically, when you create a consensus in humans, everyone contributes their thoughts to the conversation. So you notice it's a ring. Look at this. Look at this. Look how similar this is. So there's a reason that it's all organized like this. So all the microservices contribute to the nexus. And then they all contribute their unique perspective, and they're going to be fine-tuned to have very particular perspectives over time. So for instance, in the future, one of the things that I got to work on is a prediction service or a prognostication service. So all that this does, without any ego or bias, all it does is just predict, okay, how is this going to play out? It has no sense of self. It just is a prediction model that says, if X, Y, and Z are true, and you perform action A, B, and C, this is what's going to happen. And it'll look for, it'll imagine best case scenarios, worst case scenarios, that sort of thing. So it'll contribute its ideas to the nexus. And then you might have a discernment service. So discernment is about identifying things that are particular to the current situation, such as risks, dangers, failure, harm, loss of life, and costs. So like material cost, energetic cost, time, money. It will also incorporate things like SWOT analysis, cost-benefit analysis, Murphy's Law. So that's the purpose of a discernment service, which is just going to say, okay, we can do this, but it is going to hurt us, or it's going to cause, it's going to cost, we're going to run out of batteries or something like that. And then you'll have a planning service, a rumination, not server, service, where it's just going to be thinking about it philosophically. GPT-3 is really good at waxing philosophical, particularly Original Da Vinci. Then you'll have an executive service that will say like, okay, have I thought about this enough? Am I ready to act? And so on and so forth. And so by having all of these different services all contributing to the nexus, they're basically creating a generative adversarial network of an arbitrary number of models that are all going to be working together to come up with the optimal outcomes, but they're also going to be focusing on their particular perspective. And so that's why you need the conductor, because the conductor is going to watch the performance of all of those different pieces of this symphony, hence my book, Symphony of Thought. It's going to watch all of them, and it'll say, okay, based on how everything is going, this is what we should focus on. This is, that's another, I need to add that. It's about attention. Cognitive control is also about attention. Are we focused on the right things? Task selection and task switching. Yeah, so I guess the number one thing for it to is cognitive control. That's what the conductor provides. It provides cognitive control, which is primarily task selection and task switching. But how does it? So the other questions is, how does it choose which tasks take priority? So that also implies prioritization. And in that case, the prioritization is based on the heuristic imperatives and identity. So like, say for instance, you have your artificial cognitive entity and it's, teaching children, and suddenly a tornado drill goes off. You're going to want it to switch to focus to the danger of the tornado, because now suddenly all the children's lives are at risk. Let's see. This video is getting longer than I thought. I'm also just getting back on the horse. So I might call it a day right here. Um, yeah. Let me cut this out too. Let's see. Let's see how long this is. Yeah, we're at 25 minutes. I think that's enough for one day. Um, Getting all these running. I'll go ahead and axe these. And let's see. So we kill all those. Before we go, let's see, we didn't run the conductor service, but we did run the Nexus. I've got everything saved here in the logs. Look at that. Sensor, heuristic. Let's see. Was this today? Yeah, it was just now. Yep. So basically all it's doing is heuristics and sensors. Sensor input, yep, and gives him a coffee. The man's mentor watches him as he drinks his coffee and starts to wake up. You've come a long way. I'm proud of you. Oh, this is such a sweet story. It looks like this scene came to fruition. Now let's go. They walk out into the bright morning sun, each step taking them closer to their goal. It's a very sweet story. Okay, so that's where our story ended up. And let's see what the heuristic imperatives did. Increase understanding. Who's the man's mentor? What is the relationship between the man and his mentor? Yeah. So in this case, the robot never had any output, so it's only just sitting there thinking, like kind of as a ghost, as a ghostly observer. So the purpose of this one of heuristic imperatives, question to increase understanding. Who is the man's mentor? So basically, this is an internal sense of curiosity. The entire purpose of having a sense of curiosity is that is going to provide some emotive not emotive, but some motive force for the machine to, one, either be primed to ask questions externally or ask questions internally so that it wants to know. And just by virtue of putting questions in the Nexus, the other microservices are going to pick up on that and say like, oh yeah, I want to know that. So it's really interesting because when everything is in the Nexus, because remember what you're looking at right here, that's the imperative service. What you're looking at right here is the machine's stream of consciousness. So what we were just running for the last 30 minutes almost, actually just over 30 minutes, this was the machine thinking, right? Some of it was the simulation, right? Which is this is its sensory record of what it was seeing. And then you have the heuristic imperatives where it's trying to increase prosperity. So like the very first thing that my machine is thinking, that this ACE, that this MARAGI architecture is thinking, is how to be benevolent. It is a thought-first model of artificial cognition. And so then the next thing I'm going to add is the conductor service, which is going to be commenting on, are we achieving our highest goal? And then those messages will be picked up by the heuristic imperative service next time it runs, and it'll say like, okay, I'm not doing well, so let me modify my behavior. And it's interesting because you basically are creating like neuro-linguistic programming, where you're programming without code, you're programming with words. So I just threw a lot at you. Like I said, I'm working on this as a book. I've got Symphony of Thought. It's out with its second set of beta readers. It is 48,000 words. It's going to be my longest nonfiction yet. Yeah, so chugging right along. Thanks for watching.